Maybe I should actually be recording this, huh? All right, now what do I do? Divide by 2. Sorry, YouTube, I just started recording. I'm a little off today. If you search my channel, you can find one from previous years. All right, so I got L is equal to 240 minus 2W. If I know that this is equal to L, what can I do with it? Right there, right? This is where the magic happens. The rest is easy. Now watch what I have. I have a formula for area. It's equal to L, which we said is 240 minus 2W. Times what? Just W. If I distribute that W through, notice what I get. I get 240W minus 2W squared. That's a function that represents my area in terms of its width. What? Tell me something about this function. It's a parabola that's upside down. It's a parabola that's upside down. Hey, does that parabola have a maximum or a minimum? It has a maximum. What's my goal? My goal is to find the maximum, right? Shoot, what's that spot called where the maximum happens? The vertex. I wish I had an equation for vertex. Negative b over 2a. What? Yes, you could complete the square too. We're going to use negative b over 2a instead because it's in standard form. Okay, so let's first, instead of saying xy, let's try something else. Instead of x, what variable do I have? W. Instead of y, what variable do I have? No. A. So the x value of the vertex will tell us the width. The y variable would tell us the maximum area. So let's determine this value right here, which you told me I do negative b divided by 2a. What's going to be negative b? Negative 240 divided by negative 4. And I get 60. Huh, they don't know the joke. All right, bye. Good to see you.
I know it.
Yeah, I'll show you guys. Remind me. Show you 60, okay? Got it? All right, here we go. The width is 60. We got it. What is it? It's right here. Width is 60. So negative b divided by twice your a value. Twice your a value. Now, we're almost done. What does the question ask us to find?
Dimensions.
It asks us to determine the dimensions. What dimensions should he make in order to maximize the area? Is it actually asking what the maximum area is, or is it asking what the dimensions are? Dimensions. So I've got which dimension? Width. I need the length. Is there an equation up there on the board that says L equals? Yeah, it's right here. So if you plug the width back in, 240 minus 2 times 60, I get 120. So I'm going to make 60 yards by 120 yards. And that, my friends, are the dimensions that will maximize the area. Awesome. This is a 3-day process. If all of you walked away day 1, you're like, oh, I get everything, that would be totally wrong. This is going to take us 3 days to fully understand. Yes?
40 minus 2 times W, which is...
Yes.
And that's where you're getting 120?
Yeah.
Okay.
All right. Yes. Okay, so 60 goes in for W. All right, as you guys look at the, okay, excellent. My friend Avery, everybody say hi, Avery. Hi. Avery just had a question, and she was pointing to which box do you think is the most difficult box? Which box do you think is the toughest box? 1, 2, 3, or 4? 2. Without a doubt, this is one of the magic happens. That's the toughest box. And so I'm going to show you how to try to work through that box. If you were not confused at all about how to maybe come up with this stuff, that would be abnormal. Let me help you try to figure out that piece. Are you ready? Here we go. Let's look at problem number 2, A, B, C, and D. You're going to try one of these on your own. I'll do 3 of them with you. We're just going to try to do box 2, not the whole thing. It says, find a function that models the real-life situation. The sum of 2 numbers is 24. Think about it. The sum of 2 numbers is 24. Somebody give me an expression that means that. Good. Excellent. Let's go. X plus Y is 24. Any questions so far? Let's look at the next part. It says, find a function that models their product in terms of x, which is one of its numbers. I'm trying to model their product. What would be an expression for the product of these 2 numbers? X times y. Notice how many variables I have. I have 2 variables, right? We want just 1 variable. Anytime you have 2 variables and you want 1, you have to have a secondary equation to use. Somebody think of something I could do here so that I can make one of those variables go away. Yeah, so you could do y is equal to 24 minus x. Or you could do x is equal to 24 minus y. It doesn't matter. But you solve for 1, and then what do? Substitute it right there. So product is equal to x times 24 minus x. Or 24x minus x squared. That is the product of 2 numbers that add up to 24. Got it. Thank you. Let's try it. Okay. When in doubt, just try it. This is one thing we're horrible at method, just trying something. Maddie, give me 2 numbers that add to 24. So 12 and 12 is fine. It's just a boring example. 24. Okay. Everybody agree that 20 plus 4 is what? 24. Everybody agree that's 24? Okay, what's 20 times 4? It's 80, right? Well, instead of needing both numbers, you just need 1. Watch, I'll plug in 4. 24 times 4 minus 4 squared. 24 times 4 is 96, minus 16, I get 80. So this says I just need 1 number, and it can tell us what it is. 80. Now let's use Maddie's numbers that she first shows. What did you choose? 12 and 12. Everybody agree 12 plus 12 is 24? If you plug it in here, 24 times 12 minus 12 squared actually comes up to be 144. That ends up being the maximum amount. Okay? No, we're not going to finish solving it. There's not solving for it. Our only goal right now is to just write an expression that has 1 variable instead of 2. All right, let's go to one that we can actually picture. Okay, this will help you out a little bit better. A picture is 8 inches longer than it is wide. Write a function that models the area of the picture in terms of its width. So I'm going to draw. I got a picture. Somebody give me some labels.
So W.
W. L. And it says to model the area. What's an equation for area in that situation?
Area equals width times length.
Good. Now, I don't want width times length. I want just 1 variable, not 2. Somebody see something there I can use?
Equals W plus 8.
Yep, very good. L is equal to W plus 8. Because it says the picture is 8 inches longer than it is wide. So I'm going to use this right here and plug it into there. Area is equal to W squared plus 8W. Not too bad, huh? Okay, wait a minute. I think I might be getting this.
That's it?
That's it. A rectangle has an area of 40. How is that different than the previous ones we've looked at?
It's not.
Yeah, because you're given the area. You're not looking for the area. You're given the area. So what we have is we have this rectangle, and the inside is 40. And you still have width, and you still have length. Our goal is to not write an expression for area. Our goal is to write an expression for perimeter. Somebody tell me what's the formula for perimeter of a rectangle. Nice try. 2L plus 2W. Look at my expression. I have two variables. I want one variable. I'm going to need a second equation. Can somebody come up with an equation that involves this 40?
L times W equals 40.
40 equals L times W. So I'm going to use that secondary equation in order to get rid of one of these variables. Do you want to be L equals or W equals? Okay, so we're going to divide by
L.
L. That's fine. So that tells me that width is equal to 40 over L. So what are we going to do with that 40 over L? For what?
W. Then you get 2 times L plus 2 times 40 over L. Yeah,
So 2L plus, excuse me, 80 over L?
yeah, no.
40 over L times 2 is 80 over L?
Yeah.
We good?
Yep. I guess.
Do I need to show that?
Oh, it could be 2.
2 times 40 over L. This is 2 over 1 times 40 over L. Multiply the top, multiply the bottom. Better? You try letter D on your own. Go. You're super smart. You're the best of the best. You can do it. Okay, here we go. So I drew a prism. Okay? Now, what do we know about the bottom of the prism? It's a square, meaning the dimensions are the same. So if this is X, what's that? Is everybody okay with me? We good there? Now, you had to recognize square base, and if you didn't, then you're not going to see the problem, right? I mean, you have to pick up on that. There's no question. Now, how about the height? How does the height compare to this? 3x. So, I definitely heard people have forgotten how to do volume, okay? So, I'll just refresh your memory because I know we've suppressed geometry altogether, okay? So if this is 3, and this is 2, and this is 5, the way we find the volume is we multiply 3 times 2 gives us, so that's the area of the base, and then we multiply it by 5. So we just multiply all 3 together. Yes? That's all we do for volume, just multiply the 3 together. So, let's do it. Volume equals, what happens if you multiply those 3 together? 3x cubed. Yep.
Yeah, I had like 3D equals 8. That's right.
Nice try. We try one more problem today. One more. Let's go back to Kendall. Kendall is, well, she's got a farm. And on her farm, she's got a barn. Imagine that. Okay? And it's a stinky barn. I hate stinky barns. But she's got a stinky barn. Read the problem and describe to me how is this fence different than the other fence? It's a stinky fence. Like that. What's? Yeah, does it make sense that she would say, hey, you know, I've got a limited amount of fencing to use, so I'm going to put it up against the barn, that way I don't have to use fence there. That's kind of smart, huh? Yeah, she must be a pre-calc student or something, huh? All right, so Farmer Kendall's going to put the fence there. What's her goal? Maximize the area. So I need a formula for area. What's the formula for area of that shape? Later, dude.
No, but then we're gonna have
Carve a pumpkin this weekend.
minus 1 because you only have 3 sides.
Okay, excellent point. We'll get to that in just a second. Let's label these sides.
Well, no, that could be area.
The bottom one is right or a length. Does it really?
It doesn't matter.
Okay. Not one width.
I'm going to put the other width over there too. So how many variables do I have?
True.
2, so I'm going to need a second equation. Can somebody think of a second equation for me, please?
2W times L plus A? 2W plus L. Yeah, that's what I mean.
So if you take the 2 W's and you add it to L, you get 320,
Oh, right.
right? Like if we add up all these 3 things, you're going to get 320, right? Okay, so is it going to be easier to come up with a W equals or an L equals? So L is equal to 320 minus 2W. So I'm going to take that and I'm going to drop it right there. That's where the magic happens. That's the piece you got to figure out. That's what I was trying to help you come up with for that letter D that we struggled with. But eventually, hopefully, we can come up with it on your own. All right, here we go. What is my equation? A is equal to what? 320W minus 2W squared. That's my function. What shape does it make? Upside down parabola. Fortunately for me, an upside down parabola has a maximum. Maximum happens at the vertex. Wish I had a formula for vertex.
Negative B over 2A.
Oh yeah, hold negative b divided by 2a. I like that.
Negative B, negative 3 divided by negative 4.
Negative 320 divided by negative 4 is 80. So if you look at the vertex is W and A. W for your width, and then the Y value is area. Are we trying to find the maximum area?
Yes, maximum area.
We're trying to maximize the area. Are we trying to actually find out what the area is? We're trying to find out what the dimensions are. I know that the width is 80. How can I figure out the length? I've got this nice formula right here, don't I? It says length is equal to 320 minus 2W. 80 times 2 is 160. 320 minus 160? 160. So when it says, what dimension should she make the fence to maximize the area? She's going to go 80 feet by 160 feet.
Wait, so what's it? 80.
We did negative b divided by 2a. So we took negative 320 divided by negative 4. And we got 80.
What would happen if her bar was a long number? Are we another definition?
No. Nope. Yes.
How do, okay, I think you might have said this, but how
It's okay.
do you know, like, W is there and A is there, like, in the,
Excellent. Because you would normally write this as y is equal to 320x minus 2x squared, correct?
yeah,
So the w goes where the x's are, and the a goes where the y is.
okay.
We good? All right. Good for you in that I'm going to show you many examples. It'll take Monday and Tuesday for us to finish it up. I will not give you a problem on the test that you haven't seen before. Now, obviously, it would be great to be able to come across a problem you haven't seen before and be able to do it all on your own, right? So that's the goal. You're going to get an opportunity to try that if you want, but you don't have to. Take out your homework.